So now we are looking into injective functions. We are given here f of x equals x squared, and we are asking ourselves whether this function on the domain real numbers is an injective function. And let's draw the graph first. And as we all know, this function looks like this. Okay, so this is f of x equals x squared. And the definition of injection is as follows. So if we have f of x equals f of y, then it must follow x equals y for all x, y from the domain of f. So our domain now here is the real numbers. And as you can see here, if we have the real numbers as our domain, we have the whole x-axis. Yeah. There are actually different numbers from the x-axis which are mapping to the same value by this function. For example, we have f of minus 2 equals 4, and this is also the same f of 2. Yeah, you can see it here. We have minus 2 here and 2 here, and they are both mapping to the same value of 4. So this cannot be an injective function. Yeah, we have seen that this property is not holding. We have some values in our target domain, 4, in this example, but it doesn't follow that both input values are the same. We have minus 2 and 2. So this function is not injective here. But what we can do is we can restrict the domain such that this function becomes injective. And one possibility to do it is to restrict our domain to the non-negative numbers, for example, like this. So now we have the same function, but we restricted it in the following way. We have f of x equals x squared, but now we have the real numbers bigger or equal than 0, and we are still mapping to the real numbers. And now we can prove that this function becomes injective now. So let's try to prove the definition. So this was the definition here. So this you can always use in order to try to prove that a function is injective. So let's try it. So assume f of x equals f of y for some x, y from the real numbers bigger or equal than 0. And then we have x squared equal y squared. And now we can take roots on both sides, and usually we always have two solutions. But as our values x and y are now restricted to the non-negative numbers, as you can see here and here on the graph, this is exactly equivalent to first x in brackets equals y in brackets, and this is now equivalent because we have just non-negative numbers x equals y. So it follows if f of x equals f of y for some elements of our domains, and these elements were arbitrary from our domain. And we concluded with these implications, with this chain of implications, that x must equal y. So this concludes our proof that f of x in this case, in the second case here, is indeed injective. So if this video was useful to you, please consider subscribing to this channel, leave a comment, hit the like button, and see you next time.